Welcome to solverfy.
Here we have to solve the following problem. So the mass m1 has initial horizontal velocity of v0 when it strikes mass steady state mass m2. The mass m2, the mass m1 starts moving with the angle of 30 degrees below the horizontal. So that's mass m2, and mass the mass m2 starts moving with the angle of 45 degrees above the horizontal. So that is m2. Just it's easy. M2 is not a vector. It just shows that the second mass is moving with this angle, and we have to calculate the velocity of each each mass after this collision. So let's introduce x and y axis, and let's write down the conservation of the impulse of the momentum. m1 times v0 in vector equals to m1 v1 plus m2 v2. Now let's split this equation into two projections. With respect to x-axis, m1 v0 equals to itself because it's horizontal. It equals to m1 v1. So basically we have to project this. Okay, let's label this vector as p1 and this label as p2. It will be simpler for us. And p1 equals m1 v1, p2 vector p2 equals to m2 v2. So the projections of vector p1 on the x-axis is p1 times cosine alpha. Therefore, it's m1 v1 cosine alpha plus projection of vector v2, which is m2 v2 times cosine beta. So here we have one equation with two unknowns. We need a second equation, and this equation will be projection on the y-axis. And with respect to the y-axis, we have initial vector of 0, which equals to m1 v1 times sine alpha minus m1 v1 times sine alpha plus m2 v2 times sine beta. Okay, now we have a system of two equations. Let's rearrange it a little bit. So here, now the system looks a little bit busy, so we'll just substitute parameters with unknown numbers. And so here we just keep mass in grams and speed in centimeters per second. So we have to be consistent, and then we'll get a correct result. So let's do this. The first equation changes to 60 times cosine of 30 times v1 plus m2 85 times cosine 45 times v2, right? Yeah, which equals to 60 times 50. And the second equation is 60 times sine of 30 v1 equals to 85 times sine 45 v2. So let's calculate this Yeah, let's calculate these values, these coefficients. So we have a system of two equations now with coefficients, and the nice thing about the system is that second angle was 45. That's why this number equals to this number. So let's do the substitution. So 51.96 V1 plus 30 V1 equals to 3000. Then V1 equals to 36.6 centimeters per second. And how many decimals do we need? Yeah, actually, for now, let's keep two decimal. Let's keep all the significant digits, and now we can calculate V2. So V2 equals to 30 V1 divided by 60.10, or 30 over 60.10 times 36.6 centimeters per second. Let's calculate this number. It equals 18.3 meters per second squared. So now we have the solution, which is 36.6 for V1, centimeters per second, and V2 is 18.3 centimeters per second. So we can draw the velocities to two significant digits, like in the initial velocity. Then the initial velocity would be 37 centimeters per second, and the final velocity would be 18 centimeters per second. But personally, I would prefer this number because it's slightly more precise. So here is the solution of this problem. I hope I helped you. Thank you very much for your attention. Bye.